So today we will study non-destructive test on concrete. Okay, so first let me tell you what is destructive and what is non-destructive. When we prepare a cube for to check the compressive strength, we what we do, we put that cube in compressive testing machine and check the strength. Okay, we apply the load, and the point at which the cube breaks, we note that load, and that load is, if suppose that load is P, what we do, P by cross section area is the compressive strength of that cube. Okay, so before proceeding, let's discuss what is compressive strength. Compressive strength is the strength, okay, the strength the cube can bear without any crack or any deflection. All of you can look here. Suppose this is a cube, this is the surface, P is applied, this is the cross section area. So the point up to which the cube can bear the load means the bear P up to which no crack is appear. So when crack appears, we will note that load P, and P divided by cross section area is the known as compressive strength. Okay, that may be kilonewton per mm square, newton per mm square, or kg per cm square. So this is our compressive strength. So when we test the compressive strength, the cube breaks, so that undergoes in our destructive test. Now we will test the compressive strength without breaking the structure, that may be cube or already constructed structure. In that case, we cannot break the structure, so we have to check the compressive strength by non-destructive test. There are two types are there. One is rebound hammer and another one is your ultrasonic pulse velocity test. So rebound hammer, that is also known as skimmed hammer, because in that case there is a combination of your housing, hammer mass and impact spring. Okay, so rebound hammer test is a non-destructive test method of concrete which provide rapid indication of compressive strength of concrete. We can quickly find out the compressive strength of concrete. All of you can see the picture of a rebound hammer. This is the surface, this is the rebound hammer. Here there is a lock, there is rebound number indicator, there is a graph behind, there is a housing, a hammer mass, impact spring and plunger. Let me show you the rebound hammer. All of you can see, this is the lock of the rebound hammer, this is the housing, this upper surface is the housing. Within the housing, the mass and impact spring are inside the housing. This is the mass, this is the impact spring, all are inside the housing. Okay, what you can see the plunger here, the lock here. So another two important things are there. On the one side of rebound hammer there is a rebound number, you can see, and another side there is a graph to calculate the compressive strength of cube or any structure. Okay, so in the graph you can see there are 5 lines. Okay, here 4 lines are there, one is omitted, but generally there are 5 lines. You can see in the note. Let me show you. In this note you can see there is minus 90, minus 45, 0, plus 45, plus 90. One is rebound number, x-axis, and y-axis it is the compressive strength. That is in unit of kg per cm square. So let's discuss what is this minus 90, plus 90, minus 45, plus 45 and 0. So let me show you. In this case, suppose you want to check the compressive strength of a cube. Let me draw it. This is the cube, this is the surface. So today we will discuss to find out the compressive strength of a cube without breaking the cube. Okay, so this is the surface. So remember, the width of the cube is 150 mm. Okay, so while checking the compressive strength by rebound hammer, don't take the reading near the edges. Okay, you should take in something inside portion. Okay, suppose we want to check here. So to check the compressive strength of the cube, we will take minimum 3 readings. Okay, so first what you have to do, you have to clean the surface. There is a stone piece provided with this our setup. So with this piece you have to clean the surface. Okay, so you have to put the rebound hammer. How to do it? You have to place the rebound hammer like this. This is 90 degree with the surface and this is downward. So our direction is positive. You can see here, our direction is positive. To check the compressive strength of a roof, our housing roof structure, you can check the compressive strength. So our direction is -90. Okay, there is also two things you may check by inclined direction also, that is +45 downward, -45 upward. So remember two concepts. When you use the rebound hammer, if the rebound hammer is downward direction, that is positive. When it is upward direction, that is negative. So let's come back to our case. You can see here I have placed the rebound hammer here. I will press it and lock the switch and check the reading. You can see here, when I will press this will go inside and a sound will be generated and this scale will move. Okay, then I will lock this key and note the reading. After noting down the reading, what I will do, I will check here. All of you can see the curve is here. This is x-axis is our rebound number. As I have taken downward direction, okay, that is +90. You can see the graph +90 here. So by noting the rebound number, what I will do, I can get the compressive strength in y direction, that is in kg per cm square. So let's go and we will do the practical. Okay, we will take 3 readings and after that 3 readings we will take the average and find out the compressive strength of that cube. Okay, so all of you can see, we will check the compressive strength of this cube by rebound hammer method. So first, remember, don't take the reading here near the edges. Okay, so take here. Okay, so what we will do, we will check the compressive strength of this cube. So we will take at this point. So first what we will do, we will clean the surface by this stone piece provided with this rebound hammer. So you have to rub it. So that some aggregate portion will appear. Then we will place this rebound hammer perpendicular to it in downward direction. This is 90 degree, this is +90 degree. Then we will press it. All of you can hear the sound. Now you can see the reading. The reading is, you can see the reading. The reading is 22, 24, 26. Now, the reading is 26. Okay, 90 degree. Okay, as our reading is 26, you can see here, this is 25. So our reading is 26 and our alpha is +90 degree. So we will take this graph as our reading. You can see here, this is compressive strength of cube compressive strength. So we will take 26 and we will move here to y-axis, and we will find that the compressive strength of our cube is 120 kg per cm square. Okay, so for position 1 you can see, for our first reading of 20 kg per cm square. On kole. Similarly, we can find out the, okay, similarly we have to take another two cases here for serial number 2, serial number 3. So similarly we will take two cases, two reading more, and finally after averaging all these three, taking average, we will find the compressive strength of that cube. So what we will do, first we have taken the reading here, we will take the reading here and here, and for all these three cases we will average it and find out the compressive strength of this cube. Okay.